Hi everyone, welcome back to the channel. So first of all, I want to start my video by saying that if you are new to this video or if you are new to this channel, you are watching this video for the first time, don't forget to subscribe to my channel first, okay? And you will be getting basically a lot of videos on maths over this channel. If you like maths, if you are a maths lover, then this channel is for you only. So today, if I talk about what I have taken today, so for today, I have taken two very important and very simple proofs of trigonometry. So let us quickly start with our question. So as you can see, the first question is this. We have to prove here that sine theta into 1 plus tan theta plus cos theta into 1 plus cot theta is equal to sec theta plus cosec theta. Now, this is a very important proof. This has come in the board exam also, in the previous board exam, 10th board exam, right? So if you don't know how to solve this question, how to prove this question, please watch this video till the end. This video is very helpful for you if you are a 10th class student or if you are preparing for your coming board exam. So let's start with the proof. So as you can see that we have to prove this. So let us start our solution with the left hand side. You can start with the vice versa also. You can start with the RHS and you can go till LHS. But I'm taking your LHS and I'll reach to RHS, which is right hand side. So on the LHS, we have whatever is given in the question, you have to just write on that. I'm just explaining this question from your board examination point of view because that's how you can also write out in your board exam paper. So I'm going to cover each and every step. Now, I'm not going to skip a single step here. Now, I have written the LHS here, which is sine theta into 1 plus tan theta plus cos theta into 1 plus cot theta. Now, the very first step that I'm going to do here is I'm going to multiply this sine theta with the bracket thing, okay? So, sine theta into 1 is sine theta plus sine theta into tan theta. That will become sine theta tan theta. Plus this is cos theta. Again, I'm going to do the same thing. So cos theta into 1, which is cos theta, plus cos theta into cot theta. And then the next step equals, here what I'm going to do, I'm going to write down the sine theta as it is, this sine theta also as it is, but here for tan theta, I'm going to use a formula. So remember, in the board exam, whenever you will use any formula, they expect that you are also writing the formula alongside. So don't forget to write down the formula always. So here you are going to use the formula of sine theta. So on the right hand side, you can write down the formula that you have used in your particular step. So tan theta, not sine theta. Or I can just write down here that tan theta is sine theta upon cos theta. Okay. So this is the formula I have used. So at the place of tan theta, I can write down sine theta upon cos theta. So this will become sine theta upon cos theta. Plus this cos theta I'm going to keep as it is, here also plus cos theta I'm going to keep as it is, but at the place of cot theta again I'm going to use a formula which is cos theta upon sine theta equals cot theta. So this formula I'm going to use here. So this will become cos theta upon sine theta. All right. Now remember that where you have to reach basically sec theta plus cosec theta. This is what you want. All right. So accordingly move ahead. So here we have sine theta plus this is sine theta into sine theta. This will become sine square theta upon cos theta plus this cos theta as it is, and there we have cos theta into cos theta. That will become cos square theta upon sine theta. Now here I'm going to do one step, okay? I'm going to write down, okay, just a second. Yes, so I'm going to write down the sine theta and this cos square theta together, all right? So this sine theta and then this cos square theta upon sine theta together. See, this will come automatically to you or to your mind when you will start practicing. It's like you can ask why we are writing that and that together. How will we come to know in the exam that we have to write on this and this together? So for that, the only thing that you can do from your side is practice. So practice and practice, you will automatically start getting that what do you have to do in the next step. So here I know that sine theta and this cos square theta upon sine theta, if I'll write down together, I'm going to reach to my answer. Okay. And then plus this together, this and this. So this will become sine square theta upon cos theta plus cos theta. Now what I'm going to do, I am going to take LCM here. Okay. So if I'm going to solve these two parts, sine theta plus cos square theta upon sine theta, here if I take LCM, so this will become sine square theta plus cos square theta and then upon sine theta. Now, I hope you understood why I kept these two terms together, because by keeping these two terms together, I can see that I can see a formula, a very famous trigonometric formula, in fact, which is sine square theta plus cos square theta. So that is why I kept these two terms together. Now, the same thing I'm going to do here also. I'm going to take LCM and this will become sine square theta plus cos theta into cos theta, which is cos square theta upon cos theta. Now, we know a very, very famous trigonometric identity, which is sine square theta plus cos square theta equals 1. So since sine square theta plus cos square theta equals 1. So using this formula, we can directly substitute at the place of sine square theta plus cos square theta 1. So 1 upon sine theta. All right. And then plus here also sine square theta plus cos square theta, which is 1 upon cos theta. Now, as you can see that we have to prove, okay, if I'll just show you the question, just a second, and yes, you can see here that we have to bring the sec theta plus cos sec theta, right? And we have reached to this step, 1 upon sine theta plus 1 upon cos theta. So here you can again use the formula, because we know that 1 upon sine theta is nothing but cos sec theta using the formula. If you don't know the formulas of trigonometry, I have made a full video, part 1 and part 2 on trigonometry, all formulas. Okay, so I'm going to put the link in the description box of the trigonometry, all trigonometric formulas, class 10 to 12. So you can also watch that video if you have not watched the video till now. Okay, so I'm going to put the link in the description box. So don't forget to watch that video also. All right, so 1 upon sine theta formula is cos sec theta, and 1 upon cos theta, the formula is sec theta. So using these two formulas, I'm going to write down 1 upon sine theta cos sec theta plus 1 upon cos theta sec theta. And you can see that this is nothing but our RHS, the right hand side, which we wanted to prove. So is equal to right hand side. And hence LHS, that means left hand side, equals right hand side. We have proved. So we have proved this. Okay, so this is how you can solve this particular question. Now let us go to our one more question. I have taken basically two questions. Okay, so this is our second question. Now this is also a proof question. Okay, so let us understand how we can solve this question. So again, here also I'm going to start with the LHS. So on the left hand side, you can see that we have 1 plus sine theta minus cos theta upon 1 plus sine theta plus cos theta whole square. And we have to prove that this equals 1 minus cos theta upon 1 plus cos theta. So let us start with the proof. So here I'm going to just do one thing, that I'm going to write down this 1 plus sine theta in a small bracket. Okay, I can do that. Minus cos theta. The same thing I'm going to do in the denominator as well. 1 plus sine theta in a small bracket, and then plus cos theta and then whole square. Now, here what I'm going to do, you know that if we have something like this, a upon b whole square, that is same as a square upon b square. So this power we can distribute to the numerator as well as denominator. So using this formula, I can distribute this power and I can write down the next step as 1 plus, okay, 1 plus sine theta minus cos theta, okay, whole square upon again 1 plus sine theta, and then plus cos theta, and then whole square, right? I have used this formula. Now, in the next step, I'm going to use the formula of a minus b whole square upon a plus b whole square. Now, you may ask, how can we use a minus b and a plus b? So, I'm going to consider this whole as a and this as b. Similarly, this whole as a and this as b. So, can you now see that we have a formula of a minus b whole square in the numerator and a plus b whole square in the denominator? So, let us write down the formula first. Okay, because don't forget to write down the formula. Always remember to write down the formula, whatever you are using, okay, on the right hand side. So a minus b whole square, everyone knows the formula, a square plus b square minus twice of ab. And a plus b whole square, very simple, all of you know this. A square plus b square plus twice of ab. Now, using this formula, we can move ahead. All right. Yes. Okay. So if I use that formula, the numerator will become a minus b whole square, which is a square. So a is 1 plus sine theta. So this will become 1 plus sine theta, a square, plus b square. B is cos theta. So cos theta square, which is cos square theta, minus twice of ab. So twice of a is 1 plus sine theta and b is cos theta, which is same as 2 cos theta into 1 plus sine theta. Okay, we have used the formula of 1 a minus b whole square. Now here we have to write down now the denominator, and we are going to use the formula, and the formula is a plus b whole square. So similarly, this will become 1 plus sine theta whole square plus cos square theta, and then this time it's plus twice of ab. So plus 2 cos theta, and a is 1 plus sine theta. Now we are almost reaching towards the answer. So now we can again use the formula here of a plus b whole square, because 1 plus sine theta whole square is again in the form of a plus b whole square. So if you're using the same formula, you don't have to repeat it. You can directly use the formula here. So a plus b whole square is a square plus b square plus 2ab. So a square plus b square, which is sine square theta, plus twice of ab. So 2 into 1, which is 2, and then sine theta. All right, and then plus cos square theta minus twice of cos theta into 1 plus sine theta as it is. All right, and then upon. Okay, and then we have upon. The same thing I'm going to do in the denominator also. So this is 1 plus sine theta whole square using the formula a square plus b square plus twice of ab, which is 2 sine theta plus cos square theta. All right, and then plus 2 cos theta, 1 plus sine theta. All right, and now you can see here one thing. I'm going to highlight that. So sine square theta plus cos square theta. As I already told you that this is a very, very famous trigonometric identity, that the value of sine square theta plus cos square theta is 1. So in the denominator also we have the same thing, right? So now we can write down our next step as 1 plus. Now sine square theta plus cos square theta is 1. If you want, you can also use the formula. You can write down the formula here, that sine square theta plus cos square theta equals 1. So using this formula, sine square theta plus cos square theta is 1. Okay, and then plus 2 sine theta. Now this plus cos square theta we have already used. So now the next thing, minus 2 cos theta into 1 plus sine theta. All right, and then upon, we are going to write down the same thing in the denominator. All right, so this will become 1 plus, again sine square theta plus cos square theta is 1. So that will become 1 plus 2 sine theta as it is. And then we have plus 2 cos theta into 1 plus sine theta. All right. And then the next step, very simple, very much obvious, that 1 plus 1 is 2. So 2 plus 2 sine theta. all right, minus twice of cos theta into 1 plus sin theta, all right, upon this will become 1 plus 1, 2 plus 2 sin theta plus 2 cos theta upon 1 plus sin theta, all right. Now, in the next step, I can, of course, take here 2 common from these two terms, 2 plus 2 sin theta. I can take 2 common. So 2, if I'm taking common, I'm getting 1 plus sin theta, all right. Now, minus twice of cos theta into 1 plus sin theta as it is, and then upon, we have again the same thing. We can take here 2 common, so twice of 1 plus sin theta plus 2 cos theta into 1 plus sin theta. Now, here you can also notice one thing, that we have 1 plus sin theta, 1 plus sin theta common. Same in the denominator also. So can we not take that 1 plus sin theta common? Of course we can take. So we are going to take that common. Also we can take this 2 common because 2 is also here. So this will become twice of 1 plus sin theta is common. And now what is left? 1 minus twice of cos theta. Sorry, not twice of, because 2 we have already taken common. So 1 minus cos theta, that's it. All right, 1 minus cos theta. Same in the denominator. All right. Here also we can take that twice of 1 plus sin theta common. This will become twice of 1 plus sin theta. And then in the denominator, we have 1 plus cos theta. All right. And now we can cancel this. So we are left with 1 minus cos theta upon 1 plus cos theta. And do you know that this is our right hand side? Hence, we have proved. And that is the end of our proof. All right. So that is the end of this video. Also, I hope you have understood this video. I hope you have understood both the proofs. So if you have not understood the proof, please let me know in the comment section so that I can work on that and I can come up with a different thing. Okay. So please let me know about it, whether you like the video or not, in the comment section. And yes, in the next basically video, I'm going to come with a next question. Okay, I'm going to cover all the important questions in my videos. So please subscribe to my channel. Thank you so much for your love and for your support. Thank you. See you in the next video soon.